I want to do an example of a problem that I discussed in class. We're going to get a quantitative diagram. That means we're going to actually calculate the forces on this box. We're going to draw the diagram and calculate the magnitude or the size of these forces. I gave you 6 steps in class in order to make this easier. If you follow these 6 steps, things should go well. Very first thing we want to do is draw a force diagram. Step 2, if the object that we're talking about is on a ramp, we want to rotate that diagram. Third step is to find the components of any angled forces. Fourth step is to evaluate the motion in both the x and the y direction. Fifth step, find the sum of the forces in the x and y direction. Step 6 is to use the equations that you find in step 5 to solve for the unknown forces. Let's go ahead and use this example here and work it out using these 6 steps and see what happens. So the first thing I want to do is draw a force diagram. So here's my box, and I've got the force of weight acting downward, and I've got the normal force acting at an angle. You know what, I forgot to throw in an angle. Let's make this a 30-degree angle. So I've got this box sitting on this ramp, and I've got a normal force acting off in this direction, and then I've got the force of friction. Since the problem does not state that it's frictionless, I do have to consider friction. So I've got friction working up the ramp up in this direction. So I've got force of friction working in this direction. Keep in mind, since that those two forces, one is acting perpendicular and one is acting parallel to the ramp, this makes a 90-degree angle. Something to keep in mind for later. Well, without step 2, if I were to just jump to step 3, find the components of the angled forces, I'd have 2 forces at an angle that I'd have to deal with. I can make this a little easier for myself by rotating this diagram in the direction of, if you will, kind of think about collapsing the ramp. If I were to flatten this ramp out, I would take this surface here and I would move it down this way 30 degrees. So what I'm going to do is I'm going to rotate my diagram in that same direction. So I'd rotate that diagram in this same direction 30 degrees to flatten out the ramp. And what will happen is I'll get the force of friction in the x direction, the force of normal in the y direction, and then the force of weight will be the only angled force I'm left with. So let's go ahead and do that. I'm going to go ahead and I'm going to twist this so that my force of friction is along the x-axis, and my normal force would be 90 degrees to that, so that would be pointed straight up. And then again, this force is going to rotate 30 degrees. So the force of weight would be off in this direction, and that angle that I would have rotated it from its original position would be 30 degrees. So I've taken care of step 1 and step 2. I'm ready to go ahead and move on to step 3. The only force that I have that has components to it, or that's at an angle, is the force of weight. So I'm going to look for the y component and the x component of that weight force. So I've got F of g in the y direction, and I've got F of g in the x direction. Now I could go ahead and calculate those right now. I might as well. I know that F of g, the way I would calculate F of g would be mass times gravity. So that's going to be 15 kilograms times 9.8 newtons per kilogram. And I wind up with a weight force of 15 times 9.8. That's going to be 147 newtons. 147 newtons. F of G in the y direction. In the y direction, that is adjacent to the 30-degree angle. So I would use cosine. So it would be 147 newtons times cosine 30 degrees. And F of G in the x direction, that would be the opposite. So I'm going to use sine. If you remember Chief SOHCAHTOA, 147 newtons times sine 30 degrees. Let me just kind of briefly outline that for you. Sine of an angle is equal to the opposite over the hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. This is my hypotenuse. 147 newtons is my hypotenuse. So this would be my opposite. This would be my adjacent to the angle, and I can just solve for the leg of the triangle that I need. All right, so I've taken and I've broken those into components, calculated the size of those components. I'm ready to go ahead and evaluate the motion in the x and the y direction. This box is just sitting here, so that means my velocity is equal to 0, which means that the change in velocity must also be equal to 0 because there is no change. It's not moving. It's always 0 degrees, or excuse me, 0 meters per second. At this point, because my change in velocity is 0, means there's no acceleration. That means the sum of the forces is also going to be equal to 0. And this is true both in the x and the y direction because this box is not moving at all. So I've evaluated my motion in both directions. And at this point, I can go ahead and figure out the sum of the forces in each direction. So what we'll do is we'll go sum of the forces in the x direction. In the x direction, I'm looking for any arrows that are horizontal. So I've got my force of friction plus the force of weight in the x direction. Those are the only two horizontal arrows. That's got to total up to 0, which means that my force of friction plus the oh, I never did finish calculating these. Let me get these here. So 147 times cosine 30 degrees is going to be equal to 127.3. So that's 127.3 newtons. And then the other force, the other component, 147 times sine 30 degrees, and that is 73.5 newtons. So force of friction plus, let's see, in the x direction, that is going to be 73.5 newtons is going to be equal to 0, which means that my force of friction is going to be equal to, oh, wait a second here. This would be in the negative direction, right? Because my arrow is pointed in the negative direction. So that's a negative. And my force of friction would wind up being 73.5 newtons to the right. And it should agree with, because it's positive, it should agree with my force of friction in my diagram, and it does. It's always a nice little spot check. I actually did that a little earlier, and that's how I knew I lost a negative sign there. So now I can go ahead and do the sum of the forces in the y direction. So I got sum forces in the y direction. That's going to be anything that's up and down. So I've got force of normal plus the force of weight in the y direction is going to add up to 0. So that means my force of normal plus a negative 127. Again, this is pointed downwards, so this is going to be negative. Negative 127.3 newtons. It's going to be equal to 0, which means that my normal force is going to be equal to a positive 127.3 newtons, or upwards. So my two unknown forces wound up being these. So I could fill in this force of friction is going to be equal to 73.5 newtons. And my force normal is equal to 127.3 newtons, and I'm done. I completed all my steps, finished the problem. Again, if you just follow the steps, things will probably go well.